Have you ever wondered why Siamese cats look like they were painted by an artist who ran out of ink halfway through? What if I told you there's a single genetic mutation that created one of the most recognizable cat breeds on Earth? And it involves the same science behind why your fingers get cold in winter. Today, we're diving deep into the extraordinary DNA that makes Siamese cats unlike any other feline on the planet. By the end of this video, you'll understand not just how these cats got their stunning appearance, but why their genetics reveal one of nature's most elegant examples of temperature-sensitive biology in action. Chapter 1. The temperature-sensitive tyrosinase gene. Let's start with the star of the show, the tyrosinase gene. Every mammal has this gene, including you and me, but Siamese cats have a very special version of it. This gene produces an enzyme called tyrosinase, which is absolutely critical for melanin production. Melanin is what gives color to skin, hair, and eyes. In most cats, tyrosinase works perfectly fine at normal body temperature. It churns out melanin consistently, giving cats their solid coat colors. But Siamese cats carry a mutated version of this gene that creates what scientists call a temperature-sensitive enzyme. But here's where it gets fascinating. The mutated tyrosinase in Siamese cats only functions properly when the temperature drops below their core body temperature. At normal cat body temperature, which hovers around 102 degrees Fahrenheit, this enzyme essentially shuts down. It stops producing melanin almost entirely. But here's the kicker. Not every part of a cat's body maintains that core temperature. The extremities like ears, face, legs, and tail are naturally cooler than the body's core. These cooler areas allow the temperature-sensitive tyrosinase to spring into action, producing melanin and creating those distinctive dark points. This is why Siamese kittens are born completely white or cream-colored. Inside the womb, they're maintained at a constant warm temperature, so their tyrosinase never activates. It's only after birth, as their extremities cool down, that those iconic dark points begin to develop. Chapter 2. The Himalayan gene and albinism connection. The technical name for this mutation is the Himalayan gene, and it's actually a form of partial albinism. True albinism would mean no melanin production at all. But Siamese cats represent what's called temperature-dependent albinism or partial albinism. This gene follows a recessive inheritance pattern, meaning both parents must carry the gene for kittens to display the pointed pattern. It's located on what's called the C gene complex, specifically the CS allele. When a cat inherits two copies of this recessive gene, one from each parent, they'll display the temperature-sensitive coloration. What makes this even more remarkable is that the same genetic mechanism exists in other animals too. Himalayan rabbits, for example, have the exact same type of temperature-sensitive tyrosinase. It's a perfect example of convergent evolution, where different species independently develop similar traits. The enzyme itself is actually quite fragile. The mutation affects the protein structure, making it unstable at higher temperatures. Think of it like a delicate machine that only works in cold conditions. When temperatures rise, the protein literally denatures and becomes non-functional. Chapter 3. Why Siamese eyes are always blue. Now let's talk about those piercing blue eyes that every Siamese cat possesses. This isn't a separate genetic trait. It's directly connected to the same tyrosinase mutation that creates their coat pattern. Eye color in cats depends on melanin production in the iris. Brown and yellow eyes contain significant amounts of melanin, while blue eyes have very little to none. Since the Siamese tyrosinase mutation severely reduces overall melanin production, these cats simply cannot produce enough pigment to create darker eye colors. The blue appearance isn't actually from blue pigment. Instead, it's caused by light scattering through the iris in a phenomenon similar to why the sky appears blue. The lack of melanin allows light to scatter, creating that distinctive crystal blue color that's become synonymous with the breed. Interestingly, all Siamese cats have blue eyes. but the intensity can vary. Some have pale, almost icy blue eyes, while others display deeper sapphire tones. This variation depends on the exact amount of melanin present and the specific structure of their iris. Chapter 4: Environmental Factors and Color Changes. Here's something that blows many people's minds. Siamese cats can actually change color based on their environment. Since their coloration depends on temperature, factors like climate, season, and even age can affect their appearance. They tend to have lighter points, while those in cooler environments develop darker, more pronounced markings. During winter months, many Siamese cats will develop darker coloration as their extremities spend more time at cooler temperatures. As these cats age, another fascinating change occurs. Older Siamese cats often develop what's called body shading, where their previously light-colored bodies begin to darken. This happens because as cats age, their circulation becomes less efficient, and their body temperature regulation changes, allowing more areas to cool down enough for melanin production. Some Siamese owners have even reported temporary color changes after their cats have been sick with fever. The elevated body temperature can actually lighten their points temporarily, though normal coloration typically returns once they recover. Chapter 5: The 4 Classic Point Variations. The original Siamese mutation creates what we call the basic pointed pattern, but selective breeding has produced 4 main variations, each with its own genetic component working alongside the temperature-sensitive tyrosinase. Seal point Siamese have dark brown to black points with cream to fawn bodies. This represents the fullest expression of melanin production in the cooler extremities. Chocolate point cats carry an additional gene that dilutes the dark pigment, creating milk chocolate-colored points against ivory bodies. Blue point Siamese showcase yet another genetic modifier called the dilution gene. This gene affects how melanin is distributed in individual hair shafts, creating a blue-gray coloration in the points. Lilac point cats combine both the chocolate and dilution genes, resulting in pale pinkish-gray points. Each of these variations still relies on that fundamental temperature-sensitive tyrosinase, but additional genes modify how the melanin appears once it's produced. It's like having the same basic recipe, but adding different ingredients to change the final flavor. Chapter 6: Health Implications and Genetic Considerations. The genetic mutation that creates the Siamese pattern isn't just cosmetic. It can have some health implications that potential owners should understand. The reduced melanin production affects more than just appearance. Melanin provides protection against ultraviolet radiation, so Siamese cats can be more susceptible to sun damage, particularly on their lighter-colored bodies. Their blue eyes, lacking protective pigment, can also be more sensitive to bright light. Some Siamese lines have developed issues with crossed eyes or kinked tails, though these traits aren't directly related to the temperature-sensitive gene. These characteristics were historically common in the breed, but have been largely bred out through selective breeding programs. The genetics behind the Siamese pattern have also been crucial in developing other pointed breeds. The same mutation has been introduced into Persian cats to create Himalayans, and into other breeds to produce color point variations. Chapter 7: Modern Breeding and Genetic Preservation. Today's Siamese breeding programs focus heavily on maintaining the genetic integrity of this remarkable mutation while improving overall health and conformation. Breeders use genetic testing to ensure proper inheritance of the temperature-sensitive gene and to avoid doubling up on potentially harmful recessive traits. The modern Siamese has actually diverged into 2 distinct types: the traditional or old-style Siamese with a more moderate body type, and the contemporary show Siamese with extremely elongated features. Both maintain the same fundamental genetic makeup regarding their pointed coloration. The preservation of authentic Siamese genetics has become increasingly important as the breed's popularity has led to some breeding practices that prioritize appearance over genetic health. Responsible breeders now focus on maintaining the breed's unique genetic heritage while ensuring robust health. Conclusion: the living laboratory. Siamese cats represent one of nature's most elegant demonstrations of environmental genetics in action. Every time you see those distinctive dark points against a pale body, you're witnessing a live example of temperature-sensitive enzyme function. This single genetic mutation has created not just a beautiful cat breed, but a living laboratory that helps scientists understand how environmental factors influence gene expression. From the temperature-dependent tyrosinase to the resulting blue eyes, every aspect of Siamese coloration tells a story of genetic adaptation and selective breeding. So the next time you encounter a Siamese cat, remember that you're looking at thousands of years of genetic history, combined with cutting-edge scientific understanding of how DNA responds to environmental conditions. These cats aren't just beautiful, they're walking examples of some of the most fascinating genetics on Earth. What aspect of Siamese genetics surprised you most? Let me know in the comments below. And don't forget to subscribe for more deep dives into the incredible science behind our favorite animals.